Hello everyone, how are you all? I hope you're enjoying our math classes. So in the last class, we studied about mathematical formulation of a convergent and a divergent sequence. And in today's lecture, I am going to introduce a concept of bounded sequences and what is the relationship between bounded sequences and convergent sequences, which is a very, very useful topic. So let us start. So we will first define what is a bounded sequence. Now we have already done what is a bounded set. So it is similar to that. So a sequence is said to be bounded if I can bound it between two real numbers. Okay. So a sequence an is said to be bounded if there exists small m and capital M such that small m is less than or equal to an is less than or equal to capital M. So if there are two real numbers such that I can limit my an between those two real numbers, then I say that my sequence is a bounded sequence. So if only m is less than or equal to an, then we say that an is bounded below. Okay. If an is less than or equal to m, we say that an is bounded above. So we can have a sequence which is only bounded from below. We can have a sequence which is only bounded from above. So let us see some examples. Example number one, if you look at the sequence an equals to n, what does it mean? It means I have the sequence of natural numbers. So you can see that 1 is less than or equal to an for all n, but there is no upper bound. Okay, because the sequence is diverging towards plus infinity. Okay, if you look at the sequence, so you can see that an is less than or equal to 0 for all n, but there is no lower bound. Okay, and we have a sequence. Now this is a sequence an equals to 1 by n. We already know that the limit of this sequence is 0. You can see that the upper bound is 1 and an is actually attaining 1 and the lower bound is 0. Equal to sign will not exist because an will never be equal to 0. An tends to 0 when n goes to infinity, but an will never be 0. So these are some sequences which are bounded above, bounded below. Okay. And the bound may or may not be attained. Let us look at example 4, minus 1, 1, minus 1, 1. So here both the bounds are attained. So an lies between 1 and minus 1. So you look at example number 4. Example number 4 is a sequence which is bounded but not convergent. Example number 3 is a sequence which is bounded as well as convergent. Example number 1 and example number 2 are the types of sequences where the sequence number 1 goes to plus infinity, that is diverging towards plus infinity, and sequence number 2 is diverging towards minus infinity. So we have different cases. So I want to have a relationship between convergent and bounded sequences. Bounded and convergent. So we have already seen that bounded sequence may or may not converge. We have seen that. So for example, the sequence minus 1, 1, minus 1, 1 is bounded plus oscillatory. So it is not converging. And we have seen the sequence 1, 1 by 2, 1 by 3. It is bounded and convergent. So if we are given that a sequence is bounded, we are not sure whether it is convergent or not. It can happen in whatever way. But what about the other way around? So if a sequence is converging, is it bounded? Now that is the question that we want to ask. So if the sequence is convergent, is it bounded? So I will not give you an answer. I will do some mathematics over here based on the last class and we will see what happens. So suppose the sequence is convergent. So suppose an is convergent to n, where L is finite. This implies that limit n tending to infinity an is equal to n. So that means given any epsilon, I will have a natural number m satisfying something, something. So let us choose an epsilon, fix an epsilon. The epsilon can be of your choice. Let me take epsilon to be 1. You can take epsilon to be anything. So let epsilon is equal to 1. So by definition of convergent sequence, there exists a natural number m such that mod an minus n is less than 1 for all n greater than or equal to m. It means minus 1 is less than an minus l is less than 1 for all n greater than or equal to m. This is called an absolute value inequality. For example, mod x less than equal to a less than equal implies minus a less than equal to x less than equal to a. So that we are using. Now add L to the entire inequality. Okay. So what we have achieved, we have seen that is less than an is less than L plus 1 for all n greater than or equal to m. It means am plus am, am plus 1, am plus 2, they are bounded by L minus 1 and L plus 1. So after the mth term, the entire sequence is bounded by L minus 1 and L plus 1. That we have seen. But we don't know about the first m minus 1 terms. So let us look at those terms. So let us consider first m minus 1 terms. Okay. So those terms will have some name. They are finite, so I can list them. So they are a1, a2, a3 till am minus 1. So whenever I have a finite set, I will have a maxima or a minima. So let small m or let small m naught be the minima of a1 till am minus 1. Or let's do it a more simple way so that in one go I'll be able to come to a conclusion. So let small m be the minimum of a1 till am minus 1 till L minus 1. And let capital M will be the maximum of a1, a2, am plus 1, L plus 1. So we already know that the sequence an is bounded below by L minus 1 and above by L plus 1 for all the terms starting from am. Okay, so we don't know what is happening to the first m minus 1 terms. So we take small m to be the minimum of the first m minus 1 terms and the lower bound L minus 1. And we take capital M to be the maximum of the first m minus 1 terms and the upper bound L plus 1. Now, if you combine this particular thing and this particular information, we will ensure that we have ensured that my an is less than or equal to capital M and greater than or equal to small. So I have bounded my sequence between two real numbers, small m and capital M. That means my sequence is bounded. So we started with the thing, what did we start with? We started with the thing that the sequence is convergent and we ended with the thing that the sequence is bounded. So we have reached a very, very important result, and the result is a convergent sequence is always bounded. But the converse isn't true. So this is a very important result as far as real analysis is concerned. This is a result which is very frequently used in MCQs by IITs and ISI. So if you know this result, you make your life easy. And also it was very wonderful to know how can we create an upper bound and a lower bound for a convergent sequence. Thank you very much. See you in the next class.